So last week, when you were going over vertical circular motion, okay, you learned essentially this, that in vertical circular motion, centripetal force is net force. Okay, and we calculate net force by using the vector sum of all forces. Okay, so if I had these cars going around this track, okay, and I was looking at, let's say one of the cars was right here at the bottom, okay, what two forces would be acting on that car in that position? Force of gravity, and what else? Normal force, force of the track. Okay, there aren't any other forces, that's it. Okay, so in that situation, I could calculate FC by going forces in minus forces out. Would that calculate the vector sum of those two forces? Okay, and it would have to be into the circle, okay, because otherwise it wouldn't move in a circle. Can that formula, forces in minus forces out, be used no matter where I am in the circle? Yes. Okay? You just have to identify which forces are acting and which way they're acting, because that's what changes in a vertical circle. Okay? The speed of the object changes because the forces acting on it change as it goes around in the circle into different positions. We are only dealing with 3 different positions here. We'll be dealing with the bottom of the vertical circle on the inside. Okay? In that case, gravity acts out. Normal force or tension, if it's something on a string, acts in. Okay? We'll be dealing with the top of the circle on the inside. Okay? Where gravity will act in, and if we're going fast enough, there might also be what? What other force down?
Normal going in?
Exactly, normal force. Okay? That's only though if you're going fast enough. Okay? If you're going just fast enough to stay in the circle, do you push on the track? No. Okay? That's why when we're whirling this thing around and around in a vertical circle, okay, if we're going just fast enough to stay in the circle, what happens to the string at the top? It gets shorter. Well, slack, right? Because I don't have to pull on it. Right now I'm moving it almost perfectly, okay, because it's just losing tension. Still moving in a perfect circle, but I'm not pulling on it at all, okay, as it goes over the top of that vertical circle. Okay? That's if you're moving at the minimum speed for that circle. Okay? That is, of course, the only point where a minimum speed is required, because it's the only place where you can fall. Okay? The other spot in a vertical circle is over the top. Okay? Gravity would act in, and okay. 2 of these 3 positions can create a feeling of apparent weightlessness. Which 2?
Would it be the one where you're inside and at the bottom, and then the one where you're outside and at the top?
Outside on the top is one of them. Okay? And the second one is inside on the top. On the bottom, I'm always going to feel my weight because the track is going to push back. Even if I'm just sitting there, right? The track is still going to push back, and I'm going to feel my weight. Okay? But on the top, I could feel weightless in either one of those situations. Could, not always. Okay? Going under the top, like this, I could feel weightless, or I could feel heavier than normal. Okay? If I'm going faster than the minimum speed, okay, do I have tension in that string? Okay. Does that thing feel heavier than normal? Definitely. Okay? But if I'm going over the top of a vertical circle, I'm either going to feel normal or lighter. Okay? You've all had this sensation when you go over the top of a small hill. Okay? If you go over the top of a small hill fairly quickly, okay, you feel a little bit lighter. It feels like your stomach is kind of moving up into your throat a little bit, okay, as you go over the top of a bump. Okay? Like maybe if you're one of those people who goes over the speed bump too fast out here. Okay? You might feel a little lighter as you're going over the top of the bump. Don't try going over that speed bump too fast. Okay? It will end badly. I've seen someone drag their transmission right out on that bump. It was an impressive launch, but the car died. Yeah. Okay? So if you're going over the top, you could feel lighter than normal, and if you go fast enough, you could feel weightless. Like if you lose contact with the road, because then you're a projectile. While you're falling, you feel weightless, and that's what you're doing. Okay, you're falling. Right. Making sense to everybody there? Okay, so those are the three situations that we could encounter. Forces in minus forces out works for all of them. You just have to determine which forces are in and which are out. Okay, on this top on the inside, normal force isn't always there if we're going the minimum speed. Okay, and on this one, top on the outside, normal force isn't always there. If you're going fast enough, it would be 0. Okay, in either one of those cases, if Fn, your apparent weight, is 0, you feel weightless. Okay. All right, now, we didn't get to watch a lot of the videos for this because the sub was here and she didn't know where my playlist was. So, okay, we're going to play some of the videos that go along with this because they're fun. Okay, so when we do that question, okay, we got our forces in minus forces out. We manipulate for tension, okay, plug in our numbers, and we get 32.7 newtons, which is more than double the actual weight of that bucket. Okay, so this thing is pulling like more than 2 G's at the bottom of that loop. Okay, it weighs more than twice what it normally weighs, or its apparent weight is more than 2 times what it normally would be. All right, everybody okay with that idea? How would that compare with up here? Would that tension be bigger or smaller? Smaller, yeah, because now gravity is pulling it towards the middle. Okay, plus it will also be going slower. With V would be smaller, okay, so it wouldn't require nearly as much tension because it's at the top where it's going the slowest. Okay, if you don't whirl that thing fast enough, are you going to get wet?
Yes.
Yes. Okay, so it'll fall out of the circle.
Would you ever ask for, like, give us the tension and ask for the force of gravity?
No, probably not, because I would have to give you the mass to do that, which means you could just go m times g to get the force of gravity.
Okay.
But what I would ask for would be like speed or radius. Okay, so you'd have to manipulate this. Instead of having mv squared over r, you'd have to find v or r. Just a little bit more algebra, nothing serious. Okay. All right, so as these vertical, as something moves through vertical circular motion, the forces acting on it change, that changes the speed, and it changes the effect, and it changes how you feel as you move through that vertical circle. Okay? Okay, let's have a look at this one. So we've got our vertical circle, and we are talking about the top of it on the inside. Okay? Rock on a string. Okay? So that means then that since they're telling us there's tension in the rope, that we're moving faster than the minimum speed. So there is tension in the rope, okay, and that's 79 newtons. And there's also gravity. There are 2 forces acting in. How many forces are acting out? None. Okay, if I'm whirling this thing around and around in a circle, the string is pulling in, gravity is pulling in, there's nothing trying to make it go out of the circle. Okay, so when we set up our forces in minus forces out, there aren't any forces out. So we simply have the tension and gravity. Okay, so we would have then mv squared over r equals 79 plus mg. Okay, everybody with me so far? Now they want to know how fast it's going. They want to know the speed. Okay, so I'm trying to isolate v. What do I do with r?
Multiply.
I multiply it over. So I'm actually going to bracket this because there's an addition operation in there. And then I'm going to divide both sides by m. M will end up here. And then I'm going to square root. So the algebra, the manipulation can get a bit involved on these kind of questions, but I mean, it's nothing you guys can't handle. Okay, so v is going to be then the square root of 79 plus 0.98 times 9.81 times 0.4 meters, yeah, the radius of 0.4 meters, okay, divided by 0.98 kilograms. Okay, when we do that, we should get 6 meters per second, okay, when we punch it in. So 79 plus 0.98 times 9.81 times 0.4 divided by 0.98. 6 meters per second. Okay, making sense? Okay. All right, I want you to try that one. Okay, we're still dealing with a vertical circle here, but now we're dealing with the bottom inside, Kevin, of the loop. Okay, bottom inside of the loop. When the people in the roller coaster are at that point, they feel 2 times heavier than normal. Think about what force you feel. Okay? You're not actually heavier than you really are. You're only apparently heavier than you actually are. What force is your apparent weight? Fn. It's important that you know that term. I use that term for Fn all the time in this unit. So watch out for the word apparent weight, or words apparent weight. Okay, give you a few minutes on this one. Bottom of the circle. Okay, so we're at the bottom of the loop on this question. Okay, what force is this? Force of gravity. Okay, what force is this? Normal force. Any other forces? That's it. One force in, one force out. Okay, so Fc is going to equal forces in, normal force, minus forces out, gravity. Okay? So we're supposed to be finding out how fast. So that's mv squared over r. That's the v we're looking for. I know how to calculate Fg. It's m times g. But they only tell me that the person feels 2 times heavier than normal. How do I write that mathematically? 2 mg. Yeah. Okay, that would be 2 times heavier than normal. So what's 2 mg minus mg?
2.
Mg. That's 2 mg minus 1 mg is mg. Right? 2 apples minus 1 apple is 1 apple. Okay? So we've got mv squared over r equals mg. And we're looking for v. What are we going to get again for our formula? Root gur. Okay? So I'm going to multiply both sides by r. M is going to cancel. Square root of g times r. Okay? So v will equal the square root of 9.81 times 35. Okay? 18.5 meters per second. Okay? Everybody with me there? Is that a pretty typical exam level question, would you think? Could certainly be a quiz question, probably an assignment question. That would make it fair for an exam too. All right? Now, try that one. What is the apparent weight of a person who has a mass of 75 kilograms as they travel over the top of a 150 meter circle? That's the radius, by the way, okay, at 22 meters per second. So still a vertical circle here. Okay, so we are going over the top of the vertical circle. Okay, that means that normal force is acting out or up, and gravity is acting down or in. Okay, so our Fc is going to equal forces in, so gravity, minus forces out, normal force. We are looking for the person's apparent weight. Since I don't want that to be a negative number, I'm going to add it over to this side, and then I'm going to subtract Fc back in its place. So Fn will equal Fg minus Fc, which will be m times g minus mv squared over r. Okay, when I plug in my numbers, okay, 75 kilograms times 9.81 minus 75 times 22 squared divided by 150. No. Okay, so their apparent weight.
Yeah, I just finished.
Hey! Their apparent weight is 4.9 times 10 to the 2 newtons. Is that what you should expect on your quiz tomorrow?
Yes.
We will post at 3:20. There is one uniform circular motion and one vertical circular motion question. There is a solutions video. Take the time to look it over so you're ready. And remember, hey! And remember that your lab reports are due on Thursday at 8:30 a.m. Make sure they're done on time.